Object data is data that gets carried around with the object. And so when you have several objects, even several objects that are based on the same class, they can have their own set of data. Let's take a look at how this is done. And we'll make a working copy of classes.py. We'll call this classes-working.py. We'll go ahead and open our working copy. And we see that we have our duck object and the Donald instance of the object. And all of the attributes in this object are code. They are methods. So let's add some data to the mix. And we'll do this by first creating a constructor by naming a method with 2 underscores and the word init and 2 more underscores. And we'll pass it a value. We'll call it color, and we'll give it a default value of white. It's always a good idea to give your variables default value unless they're absolutely going to be required. And we'll save that in an object variable. Object variable is carried with the object itself. And you remember that self is a reference to the object. So I say self._color equals color. Now I named it with an underscore for a couple of reasons. One reason is that I want to tell myself this is an attribute that I'm using locally that I'm not going to be using directly. In other words, I'm not going to be accessing this variable from outside of the object. All of the access is going to be done from methods within the object. And for the most part, unless there's a really overriding reason to access data outside of the object without a method, then it's a really good idea to only do it with a method. Let me show you what I mean. If I wanted to, I could assign a value to color here. I could say Donald._color equals blue. And down here, we'll just get rid of these and we'll print Donald._color. And so I'll save this and we'll run it. And we'll see that it says blue. And if I print this out twice, we'll see that first it says white, and then it says blue. And that's because I've gone and I've changed it here. And so this is what you call a side effect. And these can be very, very hard to keep track of. If instead, if I just say, I'm not going to do it that way at all, I'm going to do this all through accessor methods. I have a separate method for getting the color, and I call this getColor. And this will return self._color. And then I have another method for setting the color. And I'll call this one setColor. And I'll say self._color equals color. Now it's all controlled, and I can keep track of it much easier. And so if I want to print Donald's color, I can say print Donald.getColor. We'll save that and we'll run it. And if I want to change his color, then I have a method for that. Donald set color, and we'll say that that color is blue. And then we'll go ahead and print it again. Let's go ahead and save this and run it and see what it does. You might be saying to yourself, okay, so what's the difference? We just made that harder, but did we actually make it better? And the answer is, yeah, we made it better. The reason that it's better is that now the code itself has control over what happens when that gets set. Let's say when I set that color that I need to save it in a database, or that I need to do some other things. Maybe it's not just a color. Maybe it's some other controlling configuration thing. Maybe ducks that have blue feathers have to also have blue feet. So when the color gets set, then I know that I've got a method that's going to also set the color of the feeder, that's going to also save it in the database or set some attribute someplace else based on what this change is. If I'm allowing it to get set just arbitrarily from outside of the object, then I don't have that control. Then we might end up with a duck that's got blue feathers and green feet, and that would never work. By enforcing this rule, and you'll notice when you read about object-oriented code and when you learn about object-oriented techniques, using these accessor methods is a standard. And the reason for that is that it avoids side effects and it avoids the kinds of problems that can happen when you lose control over how the data is being used. Remember, one of the major advantages of object-oriented programming is the encapsulation. And once you have that encapsulation, then that gives you control. That allows you to know exactly how your data is being used. Now, the other thing that we'll notice about this is that this does not scale well. If I wanted to be able to set, say, some other flags, some other values, some other attributes, that could quickly get out of hand. If there were more than 2 or 3 of these, it would become a real problem to keep track of. So what we tend to do in Python is to use a dictionary and to use what's called keyword arguments. If instead of just setting the color like this, I allow keyword arguments, kwargs, like that, and then based on those keyword arguments, I can set the color like this. And that even allows me to have a default value of white. And then when I want to set it at the beginning, and let's just take these out here, and I can say color equals blue, like that. Save that and run it, and we get blue. And if I don't pass it the argument at all, save that and run it, then we get white. And so this scales. If I wanted to, say, set feet equals 2, I could do that. Save it and run it. Of course, I'm not setting the color, but I'm setting another attribute. And if I wanted, I could have a getter for feet. The other side of this that doesn't scale well, though, is that I'm saving the color in a variable like this. Again, that could get unwieldy. It could become difficult to keep track of. So I can use a dictionary for that as well. In fact, I could use a dictionary for all of them and just call this variables and assign it to kwargs, like that. And for my set color and get color, if I wanted to have separate accessors for those, I could still do that. I could say variables, subcolor, and assign that to the color. And I could say variables dot get color and give it a default value, and I like to use none in a circumstance like this. And I can save that. And when I run it, you'll see that we get none down here. That just tells me that Donald's color has not been set. But instead of this, we can make one of these that scales as well. Now we're really getting into some power here. We can say set variable and allow it the name. I'll call that K, and the V for value. Self.variables sub K equals V, and get variable. Return self.variables .get K or none. And now, instead of get color, I can say get variable color. Save that and run it, but I've set feet. I haven't set color, so I can just put feet in here, and then I get the number of feet. So this allows us scalability. This allows us, if we wanted to, even after Donald has been created, we could set his color, set variable, color to blue, and then down here, I can get his color as well. And now we have his flexibility. We have a very small amount of code that can do a lot of different things. So this is a technique that you will see commonly used in Python, where you're storing your object data in dictionary objects. It allows you a lot of flexibility. It allows you to use a lot of different data, a lot of flags, a lot of attributes, and to do different things with them, to save them in databases, to use them as configuration options, and to very easily be able to set them and get them and control them. So this is one method. Obviously, it's not the only method, and we'll see a lot of examples throughout the rest of this course of different ways to handle object data. But this is, in a nutshell, how you use object data with objects and classes in Python.